Hello everyone, and welcome to the GTAC Tech Talk webinar on Advanced Motion Detection in Security Center. Thanks for joining us today. My name is Derek Schaefer. I'm a Technical Training e-Content Specialist with Genetec, and I'll be hosting the webinar for you today. We also have some other members of the Genetec Technical Assistance Center standing by who will be assisting with the webinar questions and answers. Today we have Martina Dimitrova with us, who is one of our technical support engineers with the video team. And also helping with questions and keeping everything running smoothly is Scott McFall. Scott is an e-content specialist with the Genetec Technical Assistance Center. If you have any questions during the webinar, you can just type them in the question box of the GoToWebinar console, and one of us will get back to you with an answer as soon as possible. In case we need to verify any information for your question, we'll make a note of it and get back to you via email as soon as we have an answer. All the questions and answers from the webinar will be posted on the GTAC Tech Talk section of the Genetec Technical Assistance Portal forums a day or two after the webinar has finished. If you do have any additional questions or comments on the webinar or the GTAC Tech Talk webinar series in general, you can post them in this section of the GTAP forum as well. All the videos of the previous webinars can be found by going to the resources section right here, then go to videos, and it should be on the GTAC Tech Talk section here by default, otherwise just click on it right there. And there's two ways that you can watch these, either streaming in a browser window by clicking on this icon right here, or you can download a zip to Windows media file by clicking on the second icon right here. If you'd like to receive emails concerning the latest additions to the Genetec Technical Assistance Portal, you can log into the GTAP, go to the My Account section up top here, and click on Email and Notifications. From the Notifications section down below, you can check the boxes of the subjects you're interested in, and you can select how often you'd like to receive an email when there have been additions to those sections. To put a checkbox next to a subject, the frequency here will have to be set to daily or weekly. Otherwise, the options here will be grayed out. You can also edit your subscription to our two Genetec newsletters in the email subscriptions section right up top here. And don't forget, of course, to hit the submit button on the bottom to save your changes. Now, before we get started, I wanted to talk a little about what we're going to accomplish with the webinar today. Now, we've done some general overviews of motion detection in previous webinars, but in this one we really wanted to get into some detail on setting it up and possible problems you might run into. So with that in mind, we still want to briefly cover the basics just as a refresher for some and a bit of extra knowledge for others. Now, we see some common issues when trying to set up motion detection for a particular scene in support, and we want to give you some extra information on how you can get the best motion detection results in those circumstances. There are some advanced settings available when doing motion detection using H.264 compression, so we'll take a look at how the H.264 compression works and how this affects our motion detection results. And of course, our goal is to give you the knowledge to fix any issues you run into in the field, so we'll have a quick look at how to resolve some typical problems at the end of the webinar. Going over the agenda for today, the first thing we're going to look at are the types of motion detection, such as on the unit versus the archiver, and full screen versus using zones. After that, we're going to take a look at the basic settings and how they affect motion detection results. And next, we've taken 4 common scenarios that cause problems, and we're going to look at how to set up the motion detection to get around those issues. Our section on H.264 motion detection is next, where we'll talk about the encoding settings for an H.264 stream and how we can fine-tune our motion detection process using them. Now finally, as I mentioned, we have some troubleshooting tips for any common problems you might run into. One thing I just want to point out, it's a new thing we're doing with the GTAC Tech Talk webinars, is we've got a little section on the side here, basically with this agenda. So if you need to go back and watch the webinar again and you're looking for a particular section, keep an eye on the pointer. It'll tell you what point we're at during the webinar. It makes it pretty easy to go back through and jump around through the video if you need to. So let's start out with a few basics about motion detection, just to make sure everyone's on the same page. The video image is broken down into sections or blocks, and each block is analyzed to see if it has changed compared to the previous frame. Depending on the number of blocks that have changed, we get a motion percentage. The important thing to remember here is that we're not reacting based on the motion percentage, but on the motion events that are generated. Events are generated when the motion percentage passes through either the motion on or motion off threshold, and there's a change in the current state. Let's take a look at a motion graph to make this maybe a little bit more clear. So looking at our scene here, we normally have very little or no motion at all, and our current state is motion off. If we get a little more motion in the scene, we pass the motion off threshold, but since our state is already off, nothing really is going to happen here. With more motion, we pass our motion on threshold. Since we're not currently in a motion on state, it will send the motion on event. If we set this camera to record on motion, the archiver would start recording at this point. Now the motion in the scene continues until it starts to drop off a bit here. Now at this point it drops below the motion on threshold, but nothing happens since this state is already on. It can go back up past the motion on threshold again, but nothing will happen as well since we're already in a motion on state. The only time that we're going to get a motion off event is when the motion level drops below the motion off threshold. The state will change to motion off, and if we're recording on motion, recording will stop. It's important to know what kind of motion you expect to see in a scene, so you can set the appropriate motion on and motion off thresholds. If the motion level never passes the on or off threshold, no motion events will be generated. So we take a look at this example here. If the thresholds are set too low, we're never going to get a motion on event because the motion level never passes the motion on threshold and never changes the state. Another problem can come from having thresholds set too far apart or set to extreme values. So we may pass the motion on threshold, but if the motion off threshold is set too low, it's never going to drop below this, and we'll constantly be in a motion on state. In this particular example as well, it's going to take a lot of motion just to get to the motion on state. We have it set to 40% right here. But once we hit the motion on event, we're going to be stuck in that motion state since it never drops below the 4% here. Noise in the image can be interpreted as motion, so we may have problems getting to a state where there's no motion in the scene at all. So you may never see it flatline down to 0 here. There are two types of motion detection that can be done if the video unit supports it. The first one is on the unit itself, which is sometimes called hardware motion detection. The values are sent to the unit, but the interpretation of the motion detection is being done by the hardware. Now, of course, the advantage of doing this is that all the image processing load is taken on by the unit, and there's no extra strain on the server the archiver role is running on. There are a few limitations, however. Depending on the unit and the user interface, configuring the motion detection may be a bit harder to do. With the exception of Axis video units, we only get the events from the unit and not the percentage of motion that is seen. So that means that we can't use the motion search function or see how much motion is happening in the timeline when viewing playback video. Now, one last limitation is that the unit may not support as many motion zones as we need. This would need to be confirmed with the unit manufacturer to see how many motion zones are for the particular camera that you're using. The second type of motion detection is done on the archiver, and this is sometimes called software motion detection. The advantages with using the archiver to detect motion is that you get more metadata, so basically the percentage of motion present, and that is searchable. We also have more tools available when setting up and testing the motion detection values. such as the auto calibration and the learning mode down here. Of course, the drawback with this method is it does put an extra load on the server hosting the archiver role. When searching for motion, the unit or archiver can analyze the full video image or set up multiple motion zones to exclude unwanted areas. Motion zones can have different thresholds depending on what they're looking at. You can use the tabs up top here to add or switch between motion zones, and the tools down here to add or remove blocks from the motion zone. Left clicking in the image will add blocks, and right clicking will remove them. Now please note that if zones are set up using archiver motion detection and the camera is switched over to unit motion detection, some zones may be lost depending on the number of zones the hardware supports. Let's take a look at the basic settings we need to configure for motion detection and how the detection results can be modified based on those settings. There are three basic settings to consider when we're setting up motion: the sensitivity, the thresholds, and the consecutive frame hits. And we already spoke about the motion on and off thresholds and how they are used when determining if a motion on or motion off event is generated. And I mentioned in the previous section how noise can be interpreted as motion as well, since basically it's seen as a change in the image. We use the sensitivity to adjust how much of a change should be considered as motion, and we can lower the sensitivity to reduce how much noise affects the motion level. Now, of course, we don't want to lower the sensitivity too much, or we won't see any changes in the scene at all. Similar to the thresholds, we would never use extreme values for the sensitivity either. If we have the sensitivity set to 100%, any slight change in the image will be considered, including noise, and the whole image would be considered to be in motion basically all the time. The exact values really depend on the environment the camera is in, the scene it's viewing, and the video compression being used. Lower light situations typically generate a lot more noise, as do solid colored objects, so we'd really want to lower the sensitivity a little if you have situations like that. H.264 video streams are more sensitive to changes as well, so we'll typically have the sensitivity set to about 50% or lower. We're going to take a look at that a little bit later in the H.264 section. Now the last setting that I mentioned is for consecutive frame hits. So this is the number of frames in a row that must be present to change the motion state. So if we're taking a look at a motion graph for a camera, and we see occasional spikes in the motion level, we could increase the number of consecutive frame hits that would be needed to consider a change in the motion level. For example, in our graph here, we have one frame spike here that shoots the motion level up to 60%, way past our motion on level of 30% here. So if we were set to record on motion and we had it set to one frame for the consecutive frame hits, it would actually start recording here, but basically this is a false event. It's not a usual gradual motion here. So if we set the number of consecutive frame hits to 2, that would mean that we'd need to have the motion level past the motion on threshold for at least 2 frames in a row before we would trigger the motion on event. Speaking of the event being triggered, we can change the event that is triggered in Security Center. Clicking on the Events button next to the threshold here will allow us to set which event to trigger on a motion off or motion on situation. By default they are set to motion on and motion off, but we could also create custom events such as open gate or close gate, and choose to perform actions to open or close a gate depending on if the camera sees motion in front of the gate or not. Now just note that the threshold events are part of the zone, So this way we can set up a zone that is only used by the parking gate here. And we can have other zones set up, like we have motion zone 2 here, that are set to trigger other events like the default motion on and motion off events. And this is all within the same video stream. We can test the settings we're using from the motion detection tab as well. If you're using unit motion detection, the results you get may not be 100% accurate since the test is done by the archiver, but the unit may handle the sensitivity level a little bit differently. We can choose to test the current zone or all the zones at once. Now from here we can see how many blocks are active and where we may be seeing any noise in the scene, similar to down here. Now if there is no noise or motion at all, we may want to raise the sensitivity. So if there's too much noise, we can lower it. But if you're not getting the actual motion, then you need to keep the sensitivity a little bit higher there. Now, similar to the situation, it is good to test when there is activity in front of the camera. So you can see the number of motion blocks that are active on normal motion. So this will help you set up your motion on and off thresholds. So basically, if you were setting up a scene, if you had a lobby, it would be a good idea to have a coworker standing by who would walk through the lobby at a normal pace in a similar location to where people usually would be walking by. That way you can see in the test how many blocks are active, and you can see how many blocks need to be set for the motion on and motion off thresholds. Now just bear in mind as well that using motion detection, you will not always get exact results. So you may get some motion events when there isn't motion, and occasionally it may not pick up the motion as well. So really we're just aiming for the best average results that we can get to accommodate most situations. For this reason, if you want to set up recording for a critical camera and absolutely cannot miss anything that happens in front of it, we would recommend using continuous recording in that case instead. Now just a quick tip when we're looking at the motion detection tab. If we are going to be using continuous recording on a camera and we're not doing anything with the motion events at all, it would be a good idea to turn the motion detection setting to off for that camera to basically save on the camera and archive our resources. Okay, so we're going to take a look at our detailed scenarios now and how we can adjust the settings based on them. Now there are a couple of helpful tools that can assist in setting up archive or motion detection for you, which we'll take a look at first, but it is a good idea to know how to make adjustments based on the various situations or scenarios. The first tool is used to automatically detect the sensitivity. That's the auto calibrate button right here. So if you click on that button, which is right next to the sensitivity value, you can choose which motion zone to calibrate the sensitivity for. Now before doing the calibration, make sure the image in the camera has no motion or is in the motion off state at least. If there are things in the scene that do move, like a flag or a tree, the accuracy may be compromised slightly. We'll see how we can compensate for that in a minute. When you actually run the calibration, you will see a meter that runs through for a few seconds. So the motion off state should be something that can be held for the length of time that it needs to do the calibration. Now the first choice for calibration is using the current zone. The sensitivity will be adjusted only using the motion blocks of the zone that is active below. So in this case, it's our motion zone 1. And everything else will be ignored. So motion zone 2 won't be taken into consideration, or any blocks that are outside of what we have selected for motion zone 1. Now this would be a good choice if you do have multiple zones, and one of them is more critical than the others. Now remember that the sensitivity here is set on a per camera basis, so we can have different thresholds for different zones, but the sensitivity applies for the whole camera, or the whole motion that we have here. We'll see that that can be tweaked a little bit later. We'll take a look at that. Now the next calibration option would be that would most likely be used if you have more than one motion zone, and that's using all zones here. And this is calculating the sensitivity based on all the zones that are set up for the camera. So basically it'll take the what it needs from the blocks from motion zone 1, combine the ones from motion zone 2, and exclude anything that's outside of that. So if we have any trouble spots that have been excluded from our set of zones, such as trees or flags or things like that, this will give us a good value for the sensitivity of all the important areas in the image. Now the last option here is for all motion in the image, regardless of any motion zones that have been set up. So if you have no motion zones, basically using the whole screen, or the zones take up the whole image due to overlap anyways, this is probably your best option. Now the calibration process will test the zones or image using various sensitivity values to find the one that works best in removing any background noise that it detects in the image. So just to make it a little more clear, the all motion here basically will ignore the zone. So even if there's blocks in the image that are not part of a motion zone, it's going to take that into consideration as well. Now the second tool is specific for a particular zone, and it's used to remove any trouble areas from a zone. That's the learning mode icon right down here. So when we click on the learning mode icon, any motion that happens in the view while the learning mode is active will be removed from the current zone. So before clicking on the icon, we should set up the zone with the blocks that we want to be active, or fill in the whole zone like we did in this situation. And basically to run a test here, I just selected all, put it in learning mode, and waved my arm, and you can see that it removed the area of motion from the zone here. Now for example, if we want to check for motion on a path, but we don't want to get any of the traffic from the street that runs beside it, you can run the learning mode when there's a lot of cars going by on the street, but no movement on the pathway here. Any motion blocks that see motion while we're in learning mode will be removed from the current zone, so we'll only be left with the relevant pathway here in this particular image. Alright, so we're going to move on to our 4 common scenarios where we've seen some trouble spots, or there might be something tricky in the motion configuration. We're going to look at a scene where we have solid colored objects or walls, a scene where we have unwanted movement or high contrast objects, a day versus night scenario, and a view where we have different sized objects as well. Okay, so let's look at the first scenario where we have a scene with a lot of solid colored objects, like you can see the walls in the lobby here. Now solid colors can cause a lot of noise, so in a case like this, there's a few things we can do to minimize the problem. If we run a test, if we were running the test mode on here, this is what you'd see. You'd see a lot of these random blocks popping up on the solid colors in the image here. The first thing we need to do is to adjust the sensitivity until we can get basically as little noise in the scene as possible. Now one problem with that is that we may bring it down so low that we aren't actually catching people as they walk through the lobby. So to compensate for this, we can run a test on the scene and see what the average motion blocks are like when we're seeing nothing moving in the scene. We may see that due to the noise, it only drops down to maybe like 10 to 15 blocks. So in that case, we'd want to increase our motion off threshold So it stays on until it drops below something like 25 to 30 blocks. We can use our motion zones to help out here as well. In this particular scene, most people walking by will be below the height of the logo. To compensate for the noise, we can set the zone to ignore any blocks that are at the logo height or higher. So this would be our zone, like right here. Now, places like this where there are a lot of reflections when solid walls are tricky, and it usually helps to have someone on standby to walk through, as I mentioned, just to tweak the motion detection based on what you're seeing for the motion blocks. The second scenario is where we have unwanted movement or high contrast objects. So looking at the first example is our front parking lot here, where we have some trees on the side that might cause some movement, and the flags which are blowing in the wind that would get picked up as well. Using the zone editor, we can remove those areas from our zone so they won't cause any false motion. A quick way to do this would be to use the rectangle tool, where we can click and drag to select the area, or right click and drag to remove areas from the motion zone. You can also use the pencil icon, the pencil editor, and just remove these sections along here just to fine tune it a little bit as well. Now the rest of the scene within the zone that we have here is pretty static, and we shouldn't have any problems adjusting the sensitivity to get rid of any noise and to set the thresholds to pick up any cars that are coming or going through the parking lot. Now, a second example for this is a location that has high contrast objects in it, which in this case is our chain link fence along the side here. Now, sometimes better camera placement can help, but sometimes you really just can't avoid that. The camera has to go where it has to go. So you can try to adjust the sensitivity to reduce the noise as much as possible, but something like the fence here will cause you a lot of headaches, so really the best thing is just to cut it out. You can see the fence here, it's picking up that contrast, which is why we're getting all those extra motion blocks on here and lots of noise there. So once we've cropped out our motion zone here, we can also choose to ignore the parts of the road here that are showing, so we're not picking up cars if we're just concerned with the pathway. And we also cut out the trees up top here. That's always a great idea to cut out something like that, which moves a lot as well. Alright, our third scenario is where we're looking at a scene where the lighting changes. So this can either be inside or outside, and using a regular or a day-night camera, really depending on the level of light available in the scene. So in our example here, we have the cafeteria camera showing at 1 p.m. and 1 a.m. I did actually take this on a Saturday, that's why there's nobody there. Where the lights are on a timer, and most of them shut off at 11 p.m. So in this particular situation, there are some lights that are left on in the scene, and you can see the kitchen lights are on as well. So there's no day-night camera required here, but it is a low light situation. Now, we'd have a lot of trouble trying to get good motion detection settings that would work well in both of these lighting conditions, since there really is such a drastic difference. We could set up two zones with different thresholds, but one of them would most likely be overactive at some point, and the sensitivity would have to stay the same for both. Fortunately, we do have a good solution for this, and that's using schedules. So on the top right of the motion settings, motion detection settings, are our schedule tabs. Each schedule can have completely independent values, so we can have different zones set up for it. We can have different sensitivity, and we can even choose to do unit motion detection for one and archiver for another. So in our example, we would set up a schedule for the daytime, where the lights are on from 7 a.m. to 11 p.m. And then we'd set up another one for the nighttime, covering the hours outside that. So we can adjust the settings for each one so that we can reduce the noise and we can get as many motion blocks active for movement as possible. So in this case, this is our day scenario right here, and our sensitivity, we can keep that pretty high since there won't be a lot of noise there, and our thresholds are pretty basic here. Once we switch over to the nighttime situation, we do see from doing the test that we've got a lot of noise, so we've lowered the sensitivity quite a bit, and we've changed the threshold so that it takes more motion to actually trigger that a motion on or motion off event based on the noise that's still present in the scene. And on the side here you can see that we've got our schedule set up. Now, if we find the settings for the peak daylight hours are not working so well at sunrise or sunset, we could even make a third schedule to compensate for those lighting conditions. So there really isn't any limit to how many schedules you can put in. This is our nighttime schedule here. And if we had some trouble during these times where there would be a lower light situation still, we could make a dusk and dawn schedule and include those just those hours here, 3 hours on either side, and we can have our own settings set up for that as well. Alright, so the fourth scenario is where we may have multiple sized objects in a scene, and we need to know about movement for all of them. So for example, let's take a look at our parking lot here, our side parking lot. We want to set up an event to trigger when someone is entering or leaving the parking lot. Now the problem is that we've got the entrance on the far side here. It's a little obscured by the trees. Where the cars are coming in will cover much fewer motion blocks because you can see they are much smaller in scale. Now to simplify the example here, we're going to basically ignore the lanes here. So we don't want to know about the cars moving in around the parking spaces. And we only want to really pay attention to the cars that are going in the entrance and exit lanes here. This is just to simplify the scenario, but you could actually set the zones up to cover those as well. That wouldn't be a problem. Now the best way to handle this would be to use multiple zones. We can set one up for the near lane here, and a second one for the far lane in the back. The sensitivity should be about the same for the whole scene, since the lighting and the other environmental conditions are basically the same in both zones here. Now in the near lane, we can set the thresholds much higher to compensate for the vehicles taking up more motion blocks. So we've got it set to 80 blocks on and 40 blocks for off. If we tried to use the same motion blocks for both, so a lower setting for the far lane, and that would still be used for the near lane here, it really would pick up any kind of motion here. So if we just had a squirrel run into the scene here, that would trigger our motion, and that would be unwanted motion in that case, since we're only really concerned about the cars that are coming and going here. Now of course in the far lane the cars would take up less space, so we do have the threshold set much lower here. Now since the events are bound to the motion zones, we could even set up custom events to show if someone was entering or leaving through the near lane or through the far lane. So basically we could have custom events saying near lane entrance slash exit, and another one for the far or for the near lane here saying near lane entrance exit, and do various actions based on both of those. Now if you take note that in both zones the trees have been cut out, so we won't get any tree movement in the background, and that really makes our lives a whole lot easier. Okay, so we're going to take a few minutes to go over the motion detections in H.264, as there are some differences in the way that we encode the stream, and we have some advanced settings to help adjust the motion detection sensitivity. Now, the main thing to understand first here is how the H.264 stream is encoded. An MJPEG stream is encoded by sending only the changes to the image, which basically makes motion detection a whole lot easier. In H.264 encoding, a prediction is made for where each part of the image should be based on the previous frames, and only the differences to the prediction are sent. So basically, if the motion in the image is what the H.264 encoder expected, we aren't really encoding any data at all. This prediction method is more complicated and harder to encode, but at the same time it reduces the amount of data that's being sent in video streams if you have a lot of fluid motion or no movement at all. If we get more data sent, we can assume that there are a lot of changes in the image, and therefore there is probably a lot more motion as well. There are 4 components to the H.264 encoding method, and the sensitivity can be weighted based on each one. The first thing to know is that the image is divided up into macro blocks, or 16 pixel by 16 pixel zones. For each one of these macro blocks, the luma, the chroma, and the motion vector values are calculated based on the differences between what was predicted and what the actual image looks like. Now, don't get macro blocks confused with the motion threshold blocks. They're basically only used to calculate the difference in the encoded stream, and the motion blocks are calculated separately after that based on the perceived motion in the scene. So the mapping of motion blocks is always 44 blocks by 30 blocks in a frame, and basically the pixel resolution of the block itself is based on the image, whereas the macro blocks are always 16 pixels by 16 pixels. So in this case, if we had a 640 by 480 image here, it would still be 44 blocks wide and 30 blocks vertical, divided up like that. And if you switched over to an HD stream and you had something like 1920 wide, it would still make those 44 blocks fit over the 1920. So basically, your motion block in that case would be a wider pixel width than using the 640 by 480 image. Okay, let's take a quick look at the information that is sent, starting with the luma values. Basically, the luma value is the light difference in the frame. So think of it like a black and white version of the frame, and only the differences in the light are being sent, not in the color, or being detected, I should say. The chroma is the opposite of that, where we only see the color changes, but not the changes in the light. So these two combined basically are what creates our final image here, as we can see from this example that I pulled from Wikipedia. So you can see that the light differences are taken into account by the luma here, and the color changes are by the chroma. So we're not doing a darker red here. It's just basically that's compensated for by the luma values here. The motion vectors are used to show the difference in the direction of the pixels in the macro block from the expected image to the actual image. So taking a close-up look at an image and a few of the macro blocks here, if we wanted to visually represent the motion vectors, they might look something like this, showing movement in the image going down and to the left. Now the size of the vector determines how much movement we're seeing. Now, before we look at how to set these different values for motion detection, I want to point out a few hindrances in the H.264 encoding for motion detection. Now, the main thing I want to point out is that there aren't any hard values that I can give you to help with setting the weights. Each video unit handles the encoding differently, so there are no values that work 100 excuse me, There are no values that work 100% of the time for every single unit out there. If we take a look at our motion vector example again, one encoder here, so let's say this is encoder A, may interpret the change as vectors of this size, while another one we have our encoder B. It's the exact same image, the exact same movement, but it's going to interpret that as a larger motion vector. Now, the image resolution and the bitrate may alter how the image is encoded as well. So if the image is a very high resolution, we may see larger than normal vector values, motion vector values. If the bitrate is too low, the encoder may be set to remove all motion vectors from the stream in order to save on bandwidth. This is really dependent on the hardware and how it decides to handle things. A very high bitrate may allow the encoder to be lazy and not predict as much of the image movement during the compression process, since it can just send over as much raw data as it needs, depending on the if it's got a very large bandwidth that it can use. We also need to take into account the number of iframes or keyframes that are being sent. These are the frames that contain all the information in the video image, are used as base references for the video. So basically, it's the entire image. There's no compression. There's no not sending only the changes, just the whole thing. It's just sending a frame over to basically reset the video stream. Now, if we have too many iframes coming in every second, we won't really have any changes in the macro blocks that we need, and we're going to have a hard time predicting the motion. Now, one last thing I want to point out concerning the difficulties in setting up H.264 motion detection is the difference between what we see in the config tool and what the archiver is actually doing. So when we run the live test, or we run the test in the config tool for live video, it's basically using all the frames to calculate the motion values. Now, when the archiver is actually handling the motion detection, this would really take up too many resources, so it's only running at about 10 frames per second. So when we are testing with the H.264 streams, we can set it with the config tool, but also check your results with the actual recording and events that are coming in, so you know if there are any small changes that need to be made. If we want to modify the sensitivity settings for our H.264 video stream, we can do that by clicking on the Advanced Settings button. That's next to the sensitivity field, and you will only see that if you have if you're using an H.264 video stream. From the pop-up window that comes up, we can see the adjustments that we can make to each of the 4 encoding components that we were just talking about: the luma weight, the chroma, the motion vectors, and the macro blocks here as well. So for example, if you see that your scene has more lighting contrast but solid colors, you could choose to increase the weight on the luma value and see if that helps detect motion better. Now, there are 3 settings you can choose from the drop-down menu. By default, it's custom settings. You can also choose luma emphasis, and you can choose vector emphasis as well. If you choose either the luma or the luma or vector emphasis, and you do make any changes to the values here, it's going to change that over to custom. So it's not going to overwrite the default settings for either of those presets. Now, as we mentioned, the luma emphasis is used to try to detect more motion based on the lighting differences in the video stream. And the vector emphasis is to put more weight on using motion detection, or the motion vectors, to try to detect the motion in the stream. Now, generally we can set these values anywhere from 0 to 100, or we can set them from 0 to 100. But really, in general, you shouldn't need to set them too high. So anywhere between 10 and 50, you can see, is used here. But really less is more here, so that's something to take in mind when you're modifying the weighting. Now, speaking of setting the values in the sensitivity here, we did mention this previously, but in H.264 encoding, we do want to use the sensitivity lower than 50% in most situations. Anything above that, you're going to get a ton of noise, and it'll be really hard to configure. Now, since there are a lot of factors that influence the H.264 motion detection based on the stream and the unit, the hardware that's being used, really the best course of action for configuring the values are to start with a good mid-range and tweak it in one direction or the other and see if the motion detection gets better or worse. So as we saw in the examples, we can set the advanced settings. By default, everything is 10. That's a good starting point, and then you can basically tweak one of them one way or the other, or use one of the presets and then start to raise or lower the values. And of course the same applies for setting the thresholds in your H.264 motion detection as well. Okay, so we're going to go on to some of our troubleshooting tips here. We've got about 6 of them, I believe, so we can take a quick look at those. The first problem that we see quite a bit is where the camera is not recording on motion. So basically what we're expecting is when we get a motion event that the camera should start recording, the archiver should start recording. The first thing that you want to check, of course, is that the camera is actually set to record on motion. So if you go in the camera settings and you go into the recording tab, if it's set to custom settings, you check it from here. If it's inheriting it from Archiver, check the recording tab on the Archiver itself, and check the mode. So there's the schedule, make sure it's on the right schedule, and make sure the mode is set properly as well. So manual won't do it here. We need to make sure we have it set to on motion or manual. The next thing to take a look at here is we want to see if the events are actually coming in from the monitoring task of Security Desk. So make sure that the cameras you have are actually selected for monitoring, and that you do have the motion on and motion off events selected to be received as well. So if you look in the event list up top, and there is motion in front of the camera, you should see these motion on and motion off events coming in. Now if you're not seeing these, if everything's set up properly in Security Desk and you're not seeing the events, then there could be a problem with the motion detection settings. Now alternative here is if the events are coming in, it could be actually a problem with the recording itself. So the first thing we can try to figure out which one it is go back to our recording mode and set it to continuous, and then go back and take a look at your camera in the Security Desk and see if it is recording. If we do have the red spot here and it is recording video, then we know the Archiver recording is going okay as well. If it's not, of course, there may be a problem with the Archiver. If you see a lock here and it's not recording, the first thing you want to check is make sure the database is okay. You can go to the database properties, make sure it's detecting the actual database all right. This is of course in the resources section of the Archiver role. And below that, take a look at the volumes you have selected for the Archiver, and make sure that you do have enough free space that you need and your disks aren't full, because that could cause some recording problems there too. Now the next step, of course, if we do determine that the problem is with the motion and not the Archiver recording itself, take a look at the settings, the motion detection settings that we've been looking at. A lot of times we'll see that the motion thresholds are not set correctly. Make sure that we really never want to use a 0 or 1 anywhere here. We also don't want them too close like we have in this example, or set to too high values. So a good rule of thumb is basically your motion on threshold and your motion off thresholds should be, the off threshold should be about half of the motion on. So you don't want to start too high and keep that about half. That's a good starting point. You can tweak it from there. Now another thing you might see is, if we remember our motion graphs that we saw before, is the motion level may constantly be too high. So there might be a lot of noise, like we saw in this image here. There's noise everywhere. We haven't tweaked the sensitivity yet, obviously, in this case. and that's causing problems where the motion level is constantly above the motion on threshold, and we're not getting that motion on event. So the camera will record if we get the motion on event, but it's never passing that threshold, so it's never actually sending the event. So in this case, of course we want to try to lower the sensitivity, get rid of the noise, and get the thresholds within the appropriate values. Another thing we want to take a look at is if we're not getting any motion detection when the detection is done on the unit. So in the motion detection settings, we have it set for hardware motion detection. The first thing we want to take a look at is the sensitivity. So the unit may not react like the archiver is. So everything looks fine when we're running the test in the zone. But the unit may handle things a little bit differently, so you may need to tweak that still a little bit. One thing we can try to do is take a look at the web page. So if you see this little icon here, I do have an Axis camera here that brings up this web page here, and it has a fairly decent GUI right here on the side to show the motion that's going on. If you do have a hardware unit that doesn't have a GUI like this, and they are out there, you're going to have to just set some mid-range values and just basically test in either direction and see what comes out of there. I know there's a few units that I've had to telnet into in the past that it can be a little bit of a headache, but it's doable, and you can get through it. So that's if you're only on the unit detection there. Another problem we see is we have our custom events created for the motion on and off thresholds, but they're not actually occurring. So the main thing here, you just want to make sure that the events have been assigned to the motion on and off thresholds. So creating the custom events isn't enough, or they may not have been saved. So just go back to the events button next to the thresholds, and make sure we do have the right ones assigned to the motion on and to the motion off events. Another problem we've seen is if the recording is continuing long after the motion stops in the actual image. So this is, you might be looking at your recording and somebody walks through a scene, and then you've got 5 minutes of recording after the guy has passed through the scene, and basically I'm not sure why why you have all that extra recording there. The key to look for here is in the recording tab for the camera or the archiver. If you're inheriting the settings, take a look at that time to record after a motion. Now that can be set anywhere between 0 and 300 seconds. 300 seconds is of course 5 minutes. So this is what's going to happen. It's going to keep recording after it gets that motion off event. That's really just to get a very good idea of the scene before and after the motion. You can see above we have the time to record before an event as well, so that will pad it a little bit in the beginning as well. So that's good to have something set up there, a little bit extra time. But at the same time, if you have it set too much, you're going to have a lot of empty space in your recordings there. Now, another thing you might see is if you go into your motion detection tab in the config tool for your Axis camera, and or there's no tab there whatsoever, you don't have that option at all. That's because the Axis cameras can have their own motion detection application running. It is called the Axis Video Motion Detection application. That's set up from the web page of the unit. So we need to have that disabled first. So if this is a camera that was being used previously for a different purpose, you might need to turn this off or remove it. So basically we log into the camera's web page. We go into the setup section, and on the side we go down to the applications here, and we want to select the Axis Video Motion Detection application and just click on the remove button here. It's going to take that away, and you should have your motion detection tab back for that camera. This is the other scenario, is if you're going into your config tool and your motion detection tab in the for that camera is completely blank and basically an empty tab there. The problem with this is that the always schedule may be in a particular partition that the user is not part of and cannot see. So really a best practice here is to always keep the always schedule in the public partition. That way everybody can see it. If you take a look at your motion detection settings, you'll see that they always have the always schedule there. It's not something that can be changed or removed, so that's something you want to keep in mind. Okay, so that's the end of the information we wanted to cover in the webinar for today. We're going to have a link to the PDF version of the slides in the GTAP forums when we post the questions and answers. So feel free to download that and keep it on hand if you have any issues with motion detection in the field. We're going to leave the session active for about another 10 minutes or so in case you have any additional questions for Martina, Scott, or myself. And in case you need to review the webinar or you know somebody who would like to watch it, we're going to have the video posted in the video section of the GTAP within the next couple of days. So if you have any comments or feedback on the webinar, we'd really love to hear them. Feedback is so important, and yeah, if you've noticed, we've made some changes in the past, and that's all come from feedback. That's really great to hear. When you do close the webinar, or if we end the session, you're going to be presented with a few survey questions, and we'd really appreciate it if you could just take a minute just to give us a little feedback, drop a few words in there. On the webinar today and the webinar series in general, if you have any suggestions or hints or tips for us here, that'd be great to hear. Now, if you do have any other questions you'd like to ask or have any other comments, you can leave those in the GTAC Tech Talk section of the GTAP forum, and I'll take a look at those and answer back as soon as I can. And in that section, we're also going to have the general questions and answers from today's webinar, as well as once the videos are up and the PDF slides are up, those links will be posted in the forum in there very soon as well. So on behalf of myself and everyone at the Genetec Technical Assistance Center, I'd really like to thank you very much for attending the webinar today, and we hope you all have a great day. Thank you.